I'm going to quickly walk you through this word problem. Like I said, this is an example of something that you're going to see on the test. I forgot my marker to mark it up, so I'm going to talk you through a couple things and then I'll show you the answer. So the word problem says a St. Louis zookeeper is setting up a feeding plan for a baby elephant. She plans to start the feeding at 100 pounds of food and then increase the food. And in mind you, it says food is going to be your f of x on a weekly basis. The situation can be modeled by the function f of x is equal to 100 times 1.06 to the x power, where x is representing the weeks of the feeding plan. How much will the baby elephant be eating in week 5 of the plan? It's asking us to graph the function, and then we're supposed to be talking about our domain and our range. Couple of little things to point out to you in this problem: f of x, and it's telling you that the f of x is going to be the food. So remember, f of x and y are the same thing. So as we're writing this, our y value is going to be the amount of food that the elephant is consuming for that given week. X is representing the week. So as you're making your graph, your x-axis should say week, and then your y-axis should involve food. And the food is in pounds, so pounds. Like anything that we've done, we want to make a table in order to graph this. So as you'll see on the next page, I'm going to make a table. If I were you, I would make the table first, and then I would worry about how am I going to fit it on my graph. Normally we start our tables with -2, -1, 1, and 2. But in this situation, we're trying to get to 5 weeks. So be mindful of what you're making your table, what numbers you're using as your x values, because x values is weeks. So you wouldn't put -2 and -1 on the table because that doesn't make any sense, because -2 and -1 is not possible when you're talking in terms of weeks. So you would start your graph with 0 in the x column, and then you would go 0, 1, 2, 3, 4, and 5, because we have to get it all the way to 5. So let's talk what this looks like after we do so. So I kind of have made my graph here. First thing I did was I made my table. All I did was I plugged in my week, whatever week it was, my x value into my function, and then went from there. So at 0 weeks, I'm at 100 pounds. At 1, it's 106, 2 is 112, 3 is 119, 4 is 127, and then 5 is 134. So as I am graphing this, I made sure that all of those values would fit on my x and y axis. I needed to get to 150 or 134, but I went all the way to 150. However, if you notice, I put a break in my axis because there's nothing between 0 and 100. So I started at 100 and then I went from there. It doesn't matter the increments you count by as long as you are consistent with what you're doing. And remember, you want to pick pretty numbers. So if you notice, every line is worth 5. So it's 100, 105, 110, 115, all the way up to 150. And then my weeks go all the way to, it looks like 12 is what it fits on the graph. I just needed to get to 5. All I did was graph my points and then make my function. This is exponential growth, even though it really doesn't look like exponential growth. It would start to curve upward, which is what I was trying to show with the dot that I kind of estimated was for 10, just to show you that it does eventually become exponential growth. If you continued to graph this through like week 20 or 25, your number would get bigger and bigger and bigger. The last part that I want to talk about is actually probably the most important part, which is your domain and your range, and then this word that we're going to talk about, which is limitations. So your domain. Normally, I say your domain is always just 0. However, in this not 0, your domain is always all real numbers. However, in this situation, that's not true, because your domain is weeks, and you can't have anything less than 0. So in this situation, instead of saying all real numbers, I said that x is equal to anything that is greater than or equal to 0, because you can't have negative weeks. Another limitation would also be the fact that an elephant doesn't live forever. So obviously it's not going to go on and on and on and on. But elephants live for a really long time, so you don't know when that would end. So the more reasonable limitation that you would talk about when it comes to your domain would be the fact that you wouldn't have negative weeks, so you wouldn't have anything less than 0 for your X values. When it comes to Y, the limitation for your Y values is that you're starting at 100. So when the elephant is born, it's starting at 100. So there's never going to be a number less than 100 for your Y value because that's where you're starting. So your graph would never go anywhere below 100 because that's your y-intercept, or that is your starting point. So, and the graph can't go into the negative, so then that's not possible. So I just said that 100 pounds of food is my starting point. The big thing that you really need to focus on when you're taking the test and you're doing a problem like this is being mindful and having, just thinking about what your X and Y are and being reasonable. Not having negative weeks is going to impact then your Y values, which is going to impact the amount of food the elephant can have. So that is a question that is very similar to what you'll see on the test tomorrow. Let me know if you have any questions or if something didn't make sense tomorrow before the test.